Hey guys, welcome to question MM332 of the Maths Methods Fortify study guide. So, in this question, it says, it is known that g of x is equal to x on 2 cos of x on 4, and g dash of x is equal to 1 on 2 cos x on 4, take away 1 on 8x sine of x on 4. Use this fact to find an antiderivative of x sine of x on 4. Awesome. So this is quite confusing. There's a lot of stuff being thrown around here. But let's just jump into it. So the first thing to recognize is that we're going to be having to use a concept called integration by recognition, okay? So this is a concept that a lot of students struggle with, but let's just go through the basic kind of process for it. So whenever we do, well, actually, firstly, we need to recognize that this is integration by recognition because we can't integrate this normally, right? It's almost like a product rule, and we're trying to integrate it, which we don't actually know how to do in methods. We don't learn that. So we need to do a different method called integration by recognition. So what we do is we take our original g of x and our g dash of x, and we make a relationship between those two things to find what this is. And what I mean by that is if this is the derivative of this, then this has to be the antiderivative of this, okay? So what we say is, we say that g of x, so x on 2 cos of x on 4, right? So g of x here is the same or is equal to the antiderivative of g dash of x, right? Which makes sense because if this is the derivative of that, then it has to be the same the other way around. Awesome. Now from here, what we actually want to do is we want to find the antiderivative of x sine of x on 4, okay? So we can kind of see that this bit here is almost similar to this, right? It's almost similar to what we want to get. We've just got this negative 1 on 8 out the front, which we can easily get rid of, or we can simply get rid of, I should say. So our goal is going to be to try and get this bit here by itself in the integral sign, okay? So what we're actually going to do is we're going to split these up, all right? Firstly, I'm actually going to take out half as a common factor here. So I'm going to take out a half there and a half to there. So we have half outside of integral of cos of x on 4 minus 1/4 x sine x on 4 dx. Sweet. So now we're going to actually, well, I'm going to multiply both sides by 2. So I'm going to cancel that half out. I'm going to cancel that out as well. So I'm going to get, actually, you know what? I'm just going to rewrite this here. If I multiply both sides by 2, this half is going to turn into a 1, so it's going to go away. And this x on 2 is going to change into an x. So I'm just going to make that easier for myself here. So this is what we end up with, okay? And now we want to get x sine x on 4 by itself. So our next step to do that is to separate this integral, okay? So what we do is we say that integral of cos x on 4 dx minus the integral of 1 on 4 x sine x on 4 dx. Awesome. Also, just by the way, this is our first markup here. So now our next step to getting x sine x on 4 by itself would be to just get this by itself on one side, right? So what I'm going to do is, because there's a negative out the front here, I'm going to add this to both sides, so that's going to move over here, and then I'm going to minus x cos x on 4 from both sides, all right? So what I'm going to end up with is the integral of 1 on 4 x sine x on 4 dx is equal to the integral of cos x on 4 dx minus x cos of x on 4. Awesome. Now, from here, there's multiple things we can do in this step, but I'm just going to take it step by step. So the next thing I'm going to do is I'm going to evaluate this, okay? Because we can actually evaluate this. We know how to antiderive cos in general, like just the normal cos version. So what we're actually going to do is we're going to get our cos. We're going to integrate that according to our formula sheet. Positive cos turns to positive sine when we integrate, and this 1 on 4 we're going to get out the front to 1 over 1 over 4. Okay, so we're getting 1 over whatever the coefficient of x is, sine of x on 4, oops, don't need the dx, and then we get minus x cos of x on 4, which is just this bit here. We do not need that dx there, my bad. Awesome. So then from here, this 4 then 1 over 1 over 4 is 4. So we get 4 sine of x on 4 minus x cos of x on 4. And then from here, we've got this 1/4 x sine of x on 4 here, dx. Now, because this is a constant, this 1 on 4, we can actually take that out the front. So we can take that there. And now we can see that we're looking for the integral of x sine x on 4. And we've got that here. We've just got this 1/4 out the front that's bothering us a little bit. And I should mention as well that this here will be your second mark, somewhere around there. So now we can actually pretty much solve this straight up from here. Because we're looking for this, we've got that there, we just need to get rid of this 1/4 here. So what we're going to do is divide both sides by 1/4, so that we end up with x sine of x on 4 dx, which is equal to 4 sine of x on 4 minus x cos x on 4 over 1/4, right? Because we just divided both sides by 1/4. Dividing by 1/4 is the same as multiplying by 4. So what we get is 16 sine of x on 4 minus 4x cos of x on 4, which is our integral of x sine x on 4 dx. This is exactly what we've been looking for the whole time. We've got that right now. So this bit here is our third and final mark, our final answer for MM332. Guys, I know this is a little bit confusing, so please ask me any questions that you've got in the comments below and I'll endeavor to answer them as quickly as possible. But that's it for this video, guys. Thanks for watching and I'll see you in the next one.